Welcome to the first meeting of Math Divulged. We are Math Divulged. We're a dedicated group of high school and college competition math veterans. We're here to help teach all of y'all some new stuff, hopefully, and we hope you have fun. This is going to be our first meeting, which is about test-taking problem-solving strategies. It'll be a bit different than every other meeting, mostly because this meeting we're not going to be focusing on any specific topic. Rather, we'll be talking about general problem-solving strategies, as the name says. This meeting will be around 1 hour long. It might go a bit over, but don't worry, because we'll be posting our handout, which we have, and then the recording of this meeting online after we finish. And in addition, let me introduce our program, Math Divulged, a little bit for people that have not heard of us yet. We're a group of really dedicated math veterans who are offering totally free math lessons and resources. So we'll have a bunch of 1 hour sessions and 4 types of these sessions. First is the fundamentals to improve your school math. Second, introductory to begin contest math. Third is intermediate to master the AMY. And fourth is seminar to explore unique non-competition topics. While this meeting is technically an intermediate meeting, since it's the first meeting, it's just targeted toward anybody wanting to learn more about the AMC and AMY and to be able to learn some tips about it. Our student teachers include Luke Robitaille, an IMO gold medalist. I'm pretty sure most of y'all have heard of him. He's really, really good. And myself, I'm Andrew Kai. I am a Math Counts Nationals runner-up and also an HMMT winner. If y'all have friends who are interested in math, then please share our AOPS post or our flyer with them, because the more people, the better. Next of all, let me introduce myself a little bit more. My name is Andrew Kai, and I am a current rising senior. So I'll be a 12th grader in high school next year at Clements High School in Sugar Land, Texas. I've been doing competition math for so many years now, 8 or 9 years. In those years, I've gotten second in Math Counts Nationals twice, losing to Luke both times. I've also won the combinatoric section of HMMT, which is an extremely large competition held at MIT every single year. And then I've also been a USA JMO winner and qualified for MOP, as well as qualifying for USAMO/USA JMO for 5 consecutive years. Now, this meeting, I won't be teaching, rather I'll be a TA. As a TA, I will be just giving small tidbits of information to complement Naveen's teaching. And our teacher will be Naveen Mukat, who I'll introduce shortly. If you have any questions or concerns, please direct them towards me, because I will be the only one viewing the chat. If enough people ask a specific question or have a specific concern, I may bring it up to Naveen. But most likely, like any other questions that are not frivolous, I'll probably just respond to you in chat. Our teacher, Naveen, introduce yourself.
All right, so my name is Naveen Mukat. I've been doing competitive math since about 6th grade. And in those 3 years, I had the privilege of going to Coal Valley, being in the same school as Andrew and a lot of other competitive math people. So I was able to learn a lot from them. I've made JMO. I've done AMY ever since 6th grade. Been making it every single year from the 6th to 10th. In 11th, COVID-19 kind of canceled our AMY too, so we weren't able to do much in that regard. But other than that, I also do science. I was the captain of Science Bowl in 8th grade, and Andrew was actually on our team for that year. And we ended up getting 3rd place nationals. And then last year, I was able to make it to high school nationals and get 2nd place there. So that's just about it for me. Andrew, you want to say anything?
Naveen is a really cool guy, and as you'll see, a really great teacher. And now back to about what this meeting is. So this meeting will be to give test-taking tips and problem-solving strategies, as we said. We'll be covering specific tips to help you improve on the AMC and AMY, not related to the problems themselves, but rather just general strategies to be able to use and implement. If you have to leave in the middle of the meeting, don't fret, because we'll be posting our handout and our recording online later tonight. Don't stress if you have to leave in the middle. You can just leave and then watch the rest online later. Someone asked me, is the handout just problems? No, it is not. For this meeting, the handout will just be covering the information we're covering today. In the future, the handout will not only be covering the content covered, but also give some example problems for y'all to solve, like a problem set. This meeting is just covering problem-solving tips and test-taking strategies. I don't think there's a need to give like any particular problems. The next meeting will be on Friday in 2 days. It'll be a seminar about introduction to proofs and papers. I highly recommend y'all to join and listen in. Feel free to do so. Without further ado, let's begin. Naveen.
Let's talk about the AMC series. The AMC series is a contest series run by MAA, and they do multiple contests. For 8th graders and below, they do the AMC 8, which is 25 questions, pretty easy. But their main competitions are AMC 10 and 12 and the AMY. Now, AMC 10 and 12 consist of 25 multiple choice problems, each with 5 choices. And you get 75 minutes to solve those problems. And each problem correct will net you 6 points. And each problem that you get incorrect, you get 0 points. Now, if you skip a problem, you'll get 1.5 points. Oh, and by the way, if you have questions, direct them to Andrew since I cannot see the chat right now. So with these questions, if you get a score that is higher or equal to the cutoff that is decided by MAA, for AMC 10, this is typically from 100 to 120. And for AMC 12, it's between 80 to 100. Then you qualify for the AMY. Now, AMY is very, very hard. Like, you get 3 hours to solve 15 problems. Now, that you say that's a lot of time. Trust me, it's not. Those problems can get very, very hard, especially the last 5 questions. So once you take your AMC score and your AMY score, you'll have an index. And this index will qualify you for the JMO, hopefully, or the AMO. So let's say you take the AMC 10A and you got 120 on it. And let's say you took the 10B, which is about a week later, and you got 117 on it. And then let's say that this qualified you for the AMY 1, and you get a 9 on the AMY. Now, the way your index is calculated is that you take your highest AMC score in most cases, and let's say we get 120 on 10A, so that will be 120, right? And then you take 10 times your AMY score. So you'll get 10 times 9, which is 90. And so your index will be 120 plus 90 is equal to 210. Now, this is your JMO index. And your JMO index, it can range from around 200 to 230. So this is a borderline qualifying. So more information about the 10A and 10B and about the 12A and 12B. The AMC 12 is quite more difficult than the AMC 10. Like problem 20 on the AMC 10 would be around problem 15 on the AMC 12. And the AMC 10 is only offered to 10th graders and below, while the AMC 12 can be taken by anybody in high school. And for each, you can choose to take either the 10 or 12. Like, you can take the 10A and 12B, or 12B and 10A, or both 10, or both 12, right? And you don't have to qualify on both tests. If you qualify on just one of them, you'll get your AMY qual. So let's say the cutoff over here was let's say the cutoff was 117 here, and the cutoff here was 120. You'll still qualify for AMY because your AMC 10A score was higher than your AMC than the cutoff for AMC 10A, even though your 10B cutoff was worse. Let's move on to the next part. Practice and identifying bottlenecks. So the biggest tip I can possibly give a competitor for math is to practice. Just practice as much as you can. Because practice tests, they allow you to judge your skill level and analyze specific areas of your performance. After taking many practice tests, if you want tests, there's so many on AOPS. I think the AMCs up to 1983 at least are on AOPS. I don't remember the exact number. So once you go through many practice tests, you'll know what you need to focus on. In other words, you should know your bottleneck. So what is a bottleneck? It's the main factor that prevents you from performing better. And there are usually 3 different types of bottlenecks. So your first one is accuracy. And accuracy, it can be describe as like just making a bunch of mistakes that you normally wouldn't make if you had endless time to think about it, right? So let's just say that you answered 30 questions. But on like 3 of those questions, you made a really dumb mistake. Like you said, like 2 times 3 is equal to 5 or something. This is an accuracy mistake. And most of your inaccuracies are from silly mistakes or sillies. So what you want to do is, close to the end of a contest, you want to spend around like 15 to 30 minutes to check your answers if it's an AMC test. Or if you're an Amy, since you have 3 hours, you'll spend either 30 minutes to 60 minutes to check your answers. Now, here's the thing. It's better to answer 20 questions and get each of them correct than all 25, but you miss 7. I think that math should be pretty straightforward to you. In the AMCs especially, accuracy and checking is critical. You'll catch sillies and you won't be wasting valuable time on problems that you're going to miss. Now, the next bottleneck is speed. So let's say that you have 2 competitors. Competitor 1 answers 30 questions. Let's say it's a math counts round. He answers 30 questions in the sprint round and misses 5. Now, competitor 2 answers 20 questions and gets all of them correct. Who gets the higher score? Competitor 1 does, even though he missed 5 questions. And this is why speed is very, very important. Are you accurate but slow? You need more practice on your mental math. Like, a good way to practice, just take the first 10 to 15 questions of the AMC, because these are really easy questions compared to the other 10. And do this on a very limited time constraint. Like, try to solve them all within 30 minutes or like even 20 minutes if you're brave enough. And just repeat this over and over. To complement this, play some speed math games. Like, AOPS has FTW, and I've spent a lot of time at FTW to the point where I have a 1900 rating right now because speed is too important for math. And another one would be ZetaMac. ZetaMac has some good mental math questions. Another thing is for speed, one thing that tends to slow people down is that you get stuck on certain questions. Like, suppose you just encounter a really, really hard geometry problem and you have no idea how to do. And let's say it's question 19 on 25, right? And the other 3 questions beyond it are pretty easy and you can do them decently fast. If you just go one by one without refusing to move on, you're not going to get to those questions and you're not going to get the points you can get from those questions. And this is honestly like a reason why you'll see some people actually think they're slow, but in reality, they don't know how to take their test and they're just spending too much time on one specific problem. Like, when practicing, you can set a skip timer, which means you have to skip a problem after spending a certain amount of time on it. Now, the third bottleneck that you'll find is difficult problems. And this is just, you just got to do more questions. Like, let's say that you have a weakness in geometry, like I do, and you find that's holding you back on AMCs or AVs. What do you do to solve this? You got to compile a list of geometry problems from those tests and just work through them. The greatest skill when practicing is to be able to identify your weaknesses. And let's just say that even if you're the greatest competitor on earth, there's going to be some problems that you cannot solve. So here's a strategy. Try for
also,
3 minutes. Yeah.
1 second. A few people have been asking how to spell that ZetaMac thing Naveen was talking about. So it's ZETAMAC.
Yep.
So the website is arithmetic.ZetaMac, ZETAMAC.com. It's just to like practice arithmetic speed. All right, keep going, Naveen.
All right. And like I said, there's going to be some problems that you cannot solve. And like I said earlier, just try it for 3 minutes on the AMC. You get 25 questions, 75 minutes, 3 minutes per question. Try it for 3 minutes. If you don't know how to approach it, even after those 3 minutes, just read the next few problems, see which ones you can pick off and solve. If not, just spend the remaining time checking. And with the checking part, we're going to move into our next section, which is how to avoid sillies. And with silly mistakes are the bane of so many math competitors, just because of how hard it is to get rid of them. If you don't treat them, they'll basically stay with you for your entire life, like at least your entire competitive life. So here's just some basic tips on how to avoid making silly mistakes. The first one, just read. Just read the question like 2 or 3 times, because I think this is probably the biggest reason why so many people make silly mistakes. Like, you're just not reading what you're supposed to do. Like, if your answer is in cents or dollars, if your answer is in a certain type of unit. And this is a real example, by the way, that happened on Purple Comet this year. If your answer is m over n, do you put m plus n for your answer or 10m plus n? We chose m plus n, and turns out we had to do 10m plus n. So that actually caused us to get 28 out of 30 instead of 29 out of 30. Reading goes hand in hand with another strategy, which is underlining. And underlining, it seems like a 3rd grade strategy. Okay, my handwriting just died. But underlining will allow you to identify those keywords, like those units, like what format your answer has to be in, whether you're asking for the price of a children's ticket or an adult ticket. Underlining will help you identify these. Now, when you're underlining, don't just underline the entire question. Just underline those specific things. Another benefit of it is that it forces you to read the question more carefully. Next one is organization. And organization is just saying like how good your scratch paper is. My notes just died. But let's just say that your scratch paper looks like this. Like, you solve problem 1 over here, you're like 5 plus 6 equals 11. And then you just write problem 2 over here, like 7 times 8 equals 56. And then let's just say that you're drawing a geometry problem and you just are not drawing it correctly, or it just is messy. And then you find you have some space over here, might as well just go over here and you start drawing stuff here. This is not how to do scratch paper. This is not how you're supposed to do it. This is just terrible, honestly. Because what will happen is you're more likely to lose track and disrupt your train of thought. You might miss important parts of the problem. You'll spend extra time looking for earlier computations. You'll get confused between which problem you're solving. That's not what you do. What you do is you break your paper off into sections, or you can even use the entire sheet. Like, do this, like problem 1. Problem 2. Then just do whatever here. And now you actually have a way to organize your work and actually see stuff more clearly. So make sure your problems are very organized, because otherwise bad things will happen. Next one, check your work. How many times have you ever gone to do something and said that you ended up typing? How many times has that happened to you? I'm assuming, like, if you've done a lot of contests, this has happened to you at least once. Like, I'd be very surprised if it hasn't. But checking your work, like, if you go over it later on and you see this, you'll understand something is wrong, and hopefully you'll realize it. However, what I do not want you to do is just skim the answer, because you're likely to see this and think it's perfectly fine because you already looked over it once. Your brain might autopilot and just make the same mistake again. So this is why solving problems a different way is very, very, very nice. Like, if you do 101 times 99 and you think it's let's just say it's 9998, just by looking at it, but then you solve it a different way. What if I did difference of squares? And all of a sudden you realize you get a different answer. you're not making the same computations in your head, which allows you to not autopilot. So solving a different way is a very powerful way to check your work because it will avoid you from making the same mistake over and over again. Next one, just go over your work briefly. I have no diagram for this one, but just briefly, just look over your work immediately after solving each problem. Don't don't rush ahead. Just make sure you got that problem. You know exactly what you're doing. And just make sure your process makes sense too. Like just quickly check a few key computations to make sure there's no errors. It might slow you down a bit, but after a while you get used to it and it's going to catch so many silly mistakes that you make. And it's definitely worth it. Now our last one is sanity check. Sanity check, it's basically what it sounds like, right? Let's say you got the speed of a fly. And let's say that you got your speed is, 78 miles per hour. Does this seem right to you? It doesn't seem right, right? So you might have done something wrong. And most of the time, when you have these sanity checks, you probably did something wrong. And you'll actually discover that there's some kind of computational error or you approach the problem differently. So sanity check is just make sure your answer makes sense in your head. Last one, it's not really much of a check your work type thing, but it's don't miss bubble. Please don't miss bubble. Every year we have someone that missed bubbles and loses and misses their Amy cutoff because they just marked A instead of B. And that took them down by 6 points and they fell off from the Amy cutoff. So avoiding them is worth your time. Spend the last 1 to 2 minutes to check that you bubbled all of your intended answers. Okay, let's move on to the next one. What do you do on test day? So, guys, please listen to this. Get 8 hours of sleep. This is I know that school and homework tends to make you go 6 hours of sleep, but you have to get 8 hours. Even 7, maybe 7 hours and a half, but please just go for this, whenever you can. Because I know that you feel fine running in 6 hours normally, you feel used to it, but trust me, you're not. Studies showed that after 2 weeks of sleeping for 6 hours, you had the same performance as if you pulled an all-nighter for 2 nights in a row. And the most sneaky part of this is that those participants didn't even feel like they were impaired. So even if you think that you're fine, you're not. So after you sleep, and please make sure you sleep, try to eat some kind of breakfast, protein or fiber in it, because if you just eat all carbs, all cereal and milk or something, you might sugar crash during the test. And a sugar crash during the test is not what you want to have. Another tip for just a few days before the contest, don't train too hard, because training too hard will actually put stress on you. It might tire you out. Just relax yourself and your brain. Just allow yourself to absorb all the information without actually force feeding it, right? Just review over some basic formulas, some basic strategies. Do a few problems. Don't burn yourself out. Burnout is a thing. And you have a lot of people who quit competitive maths because they got burned out from just going too intensely. What you bring to the contest? Always some water.
And one thing is, for the studying before, it's not even burning out of competition math. It's just that if you grind too much, at one point your brain is going to get slower and slower. And you don't want your brain to be like that. You want your brain to be fresh and ready for the test. So don't overexert it the few days before the test.
Yep. Make sure you stay hydrated. Just bring some water. Water helps you think. If you get dehydrated, it's a bad thing to do during the test. It will bring you down. Plus water, you feel a lot better if you're actually properly hydrated. Amy specifically, it's 3 hours, so you might want to bring some snacks or a meal. Andrew, you want to talk about those experiences?
I think every Amy I've been to, I almost every single Amy I've been to, I've brought like some snacks or like a meal or something. Because, for example, in the middle of the test, if you're feeling like, if you just feel like you can't solve anything, maybe just take a 5-10 minute break and just eat some food or drink some water, go to the restroom. Doing all that helps keep your mind refreshed, because 3 hours is a long, long time to like work on just one math test.
Another thing. All right. Just make sure you bring like some spare pencils, because you do not want to spend the time getting up, sharpening your pencil, throwing off your entire train of thought. It's not going to be good. Make sure you got pencils. If you want colored pens, bring some colored pens, especially on geometry problems. It's kind of hard to tell when everything looks like this and you got all this stuff going on. But with color, you can easily tell what's going on. Like, just ignore the bad drawing for now. But this is just a sketch on how important color is to your mind. Because now you can easily see everything, right? So erase that. And just make sure you bring some stuff, whatever feels good. Like, even if you have a good luck charm, bring it. Because it does have a significant mental effect on you. Personally, I would recommend a stuffed penguin, and I think Andrew recommended the same thing. So during the test, take some deep breaths. Don't stress out. Remember, all of these are just, the cutoffs depend on how other people do as well, right? So if the test is harder than normal for you, it's going to be harder for everyone else, and the cutoff will be lower. If it's easier for everyone else. It's just a fact, right? And a little stress is good. It helps you focus a bit. But if you stress yourself too much, it's going to distract you and you're going to feel terrible. So just have a level of stress where you like are locked in and focused, but don't overdo it. So let's just talk about the AMC for a minute again. So let's say that you think the cutoff is going to be 120. Whoops, I'm on eraser. Cutoff is going to be 120, right? Let's say you've done 19 questions and you know for sure that those are right. How many questions do you have left? You have 6 questions left. How many points do you have from those correct answers? We have 114 points from those 19 questions. Now, if you go back to our score guide, you get 1.5 points if you skip the question. So what happens if you skip all 6? Get 123 points. Now, I don't think the cutoff will ever be that high, but this is just a good general strategy, right? Like, if you have enough questions solved to make Amy and those skipped questions can carry you over the line, spend time checking these. Like, there's no point on solving the other ones unless you're going for JML. And then again, one step at a time, right? Just make sure you get those 19 ones right. Because these, you get 9 points. If you make a silly mistake, you get taken down to 117, which might not be enough to get to the 120 cutoff. So make sure you get those 19 questions right. So let's just say that you're not doing that well. Let's just say that instead of 19 questions, you've solved 17. And you have 8 questions left. How many points do you get from 17? Well, you get times 6. 1 or 2, right? What about those 8? You only get 114. So what are you going to do? If you can't solve the other 8 and you're getting a little desperate, the best thing is to guess, right? You don't really lose anything. Let's go over here. AMC 10 and 12 have 5 choices for each question.
Oh, by the way, one note on the guessing thing. But you should take into context how hard the test is, because oftentimes the cutoff can be as low as 102. But if you think the test is easier, then most likely it's going to be tending towards 120. So I recommend you use your best judgment on like how difficult the test is. And from there, you can probably estimate where the cutoff will be.
All right. So let's go to our 5 choices. 1 of them is correct. 4 of them is incorrect. So what's your expected value? Well, you get 6 points for correct. And you get 0 points if you're incorrect. So if you add that up, you get 6 over 5. So you can expect to get 1.2 points per AMC question if you're just guessing on it with 5 choices. However, what happens if you eliminate one of those choices? And all of a sudden, you have 4 choices. And instead of 4 incorrect, you have 3 incorrect. And instead of 5 total choices, you have 4, right? Watch what happens to your expected value. This expected value becomes 1.5. Now look over here. Your skipped question is 1.5. And your expected value with 4 choices is 1.5. So if you're finding yourself like scared that you're not going to make the cutoff and you don't think you're going to make it, if you're able to eliminate one choice from the AMC choices, you have the same points that you'll get. Like you can expect to get the same amount of points from guessing all of them than leaving it all blank. And the more choices you can eliminate, the higher your expected value goes. Like if you eliminate one more choice, you have an expected value of 2. If you can eliminate one more choice, you can expect 3 points. If you eliminate all of them, you get the question right. What's the point there, right? Just bubble it in already. So that's an interesting tactic you can use for making sure you can actually get scores in AMCs. And in terms of actual guessing strategies, most are pretty intuitive. Like if you have geometry diagrams and you got a ruler with you, you can kind of estimate the best answer. Like I'm pretty sure on the clock problem from a couple years ago, I think it was a problem 14, someone actually cut out the clocks and started rotating the clocks around like with scissors and paper and got the correct answer while everyone else missed it.
Just as context, this problem was a really hard problem that was placed as a number 14 on AMC 10. Almost everybody missed it, including people like me and Naveen, I recall.
Yeah.
And this problem was about like rotating like a circle with an arrow around a clock. So you have something and then you rotate the thing around the clock. So if you don't know how to do that, you can literally just cut it out and then try estimating how many rotations. Again, I recommend that you try to solve things before you try guessing them or doing estimations such as like that. But if it comes to that, then I recommend you to do that.
Okay, if you're curious, the problem was 2015 AMC 10A problem 14. So yeah, that's a pretty infamous problem. But someone solved it by cutting that paper and just rotating the clocks around. So that's one guessing strategy you can do. Another one, you can actually kind of estimate. Like if you see just 2 ridiculously large numbers and you have no idea how to solve it and asking you to multiply them, like not an actual question, but just an example, you can kind of estimate it and look at the choices and see which one seems about right. Another one, if you know that the answer has to be a multiple of 12, cut down the ones that are not a multiple of 12. Like it seems obvious when I say it out loud, but during the actual test, your mind's not going to be on this. Your mind's going to be like, how do I solve this? Just make sure, just know that you can do that still. You can still cut off stuff and hopefully use the power of expected value to get your answer and to get those points. So now we're wondering how to actually solve problems. So how to solve problems, the greatest tip is do more problems, right? Because math counts, AMC 10, AMC 12, AME, JMO, they all have they have pretty similar problems. You're not that likely to see completely novel problems. Like JMO maybe, but most problems are going to be derivatives of other problems. So if you're able to just glance at a problem and say, hey, I've seen this before, I've solved it before, or I've solved a problem that looks like this, that's insane. That's way too useful. And this is not just math too. This is coding, especially. Coding, this happens all the time. During a contest, you might not have time to experiment with multiple angles of attack on a single problem. Remember, 25 problems, 75 minutes, 3 minutes per question. You should be able to build your intuition to the point where you can glance at a problem and say, this is how you solve it. And this is how I've done it before. And someone on the AOPS thread said that someone got the 2015 AMC 10A number 14 problem by cutting it out of the booklet. Yep, that's entirely valid. But the whole point is, let's just say that you encounter a problem that you've never seen before and you have no idea how to approach it. So here's some small things. So remember, competition math is a puzzle. There's a limited amount of tools for each problem, and you have to identify those tools as quickly as possible. When you're practicing, there should be one main takeaway from each problem. What type of problem it is? Is it algebra? Is it number theory? Is it geometry? Is it combinatorics? And you got to remember the tools that you use to solve it. So here's a quick example. So let's say that you encountered this first problem. xy minus 50 equals 5x plus 12y. Now, if you're an experienced competitor, you'll know that this is Simon's favorite factoring trick just off the top of your head. It's a pretty famous trick. However, let's just say that you actually have not encountered this. Well, what do you think you should do? Well, your intuition should tell you, let's just move some stuff around. And let's just say xy minus 5x minus 12y equals 50. Just move the variables to one side. And then you see that you have this x and this x. So let's just group those together. X times y minus 5 minus 12y equals 50. And then you say, I have a y here, I have a y here. Let's group those together. Then you get this red thing right here. And then you group everything together, you get x minus 12, y minus 5 equals 110. And there you have it. You have all of your pairs by just breaking up 110 into factors, right? Like I said, incredibly powerful because the thing is, like I said earlier, most competitors have seen this kind of problem before, like most top competitors. So they won't actually spend too much time like reasoning out all of this. They'll just go straight to like maybe around to the red step, and then some of them will go straight to the purple step. And they won't spend all that time just feeling around in the dark looking for the solution, right? But you won't always be that lucky. And to have this kind of intuition to lead you to that answer, that's an underrated skill for sure.
Let me add.
Yeah.
Finish your thought.
No, I'm good.
Okay, let me add on to this a little bit. So there will, no matter what level you are, even at like my level or like Luke's level, there will be problems which you don't know intuitively how to do. And you'll have to test out some stuff, play with some stuff, try to figure out like to rearrange the problem so that you can reformulate it in a way that you know that it boils down to something you do know how to do. So in this problem, you might not know how to solve for this, but then if you can boil it down into just factoring that x minus 12 times y minus 5 is 110, that's something you know how to do. So you just have to try your best to rearrange this equation, to rearrange and reformulate the problem into the purple statement, which is something you do know how to solve and you do know how to do. And I think that's where the real skill of math competition comes in, using your intuition to reformulate a problem into like a tool that you do know how to do.
All right. Thank you, Andrew. So let's talk about some specific subjects like algebra and number theory. So if nothing actually like goes into your head, like you really don't know how to approach it, just try to rearrange the problem, right? like we saw with the Simon's favorite factoring trick problem, just move these over here and then just mess around, just play around with the numbers and see where it leads you, right? And this is most important for algebra and number theory. That's where you see this rearrangement motif more importantly. For 6.3, for geometry, just make sure you draw the problem neatly with a ruler and compass. A good diagram can make or break the entire round because, like, let's just say you were messing around with the triangle problem. Let's get rid of all this. And you're trying, let's just start off basic. You're trying to draw all of the angle bisectors, right? You do this, and you did this, and you do this. And then all of a sudden, you were not drawing neatly, and this does not look like an angle bisector to you. So if you actually decide to draw neatly, that wasn't the neatest. So just make sure you can always draw neatly.
And to draw neatly, it's best to use, again, like ruler and compass, even protractor if you need to, because all three of those tools are allowed. And yeah, Naveen doesn't really have them here, so it's a bit difficult for him.
Yeah, I do have a ruler, but it takes a lot of effort to use, and I'm not exactly acquainted with the iPad. But already you can see a good diagram can actually provide you
with
more tools.
Actually, I take back what I said. Apparently, protractors are being banned. At least someone said that in chat. I'm not sure if that's true, so it's best to check the veracity, like check if you can use protractors or not.
Yeah. So, like you said, like you see earlier, a bad drawing can result in points just not existing at all, while a good drawing can actually provide you with good points. And in case you need to guess the answer, you might be able to get it just from your good drawing. So for a combo, just try small cases. Like, let's say you had a grid. And let's just say it's a 12 by 12 grid. So I'm just going to draw a bunch of lines. Not exactly 12 by 12, but you get the point. And you want to say, how many ways are there from get to here to here? Now, if you know how to do math, like if you know how to do this kind of problem, you'll recognize that the answer is 24 choose 12. But let's just say you don't know that. Where do you start off with this problem?
Naveen, it's 24 choose. Wait, how many points are in the grid?
I said 12 by 12 grid.
Oh, all right. Yeah.
Yeah. It's not exactly 12 by 12, but I don't have that space. So how would you approach this? Well, clearly, you should be able to identify that it's a combinatorics problem, first of all. But another thing you want to do, look at small cases. Let's look at the 2 by 2 case. Let's actually look at the 1 by 1 case. How many ways are there to get from bottom left to top right? You can go this way, you can go this way. That's 2 ways. What about 2 by 2? There's actually 6 ways if you want to count them all. And if you do one more, and if you spend the time on it, if you do a 3 by 3, you see 20. You might be able to recognize the sequence as being 2n choose n. So that might lead you to the correct answer just by drawing small cases and looking at later values. You see this often with recursion. Like if you're looking for the amount of ways to fill a grid with 2 by 1 blocks. Let's just do one more example. How many ways are there to fill this with 1 by 1 blocks and with 2 by 1 blocks? Well, if you have 8, it's kind of hard to just think about it, right? But let's start small. If you have a 1 by 1 block, there's only one way to fill this out. This one, you can fill it out 2 ways. With 3 Take a guess. Fill it out 3 ways. With 4, you fill it out 5 ways. And you might start to recognize this sequence too. This is the Fibonacci sequence. And from there, you can assume that your 5 will equal to 8, 6 is 13, 7 is 21, 8 is 34. So there's 34 ways to put 1 by 1 and 2 by 1 blocks. So with combo, one of the most powerful things you can do, start small, work your way up, build up your solution. And if you're a coder, you might recognize this a little bit like dynamic programming. So yeah, that's the strategy for combo.
And in fact, that strategy has helped me a ton. A few years ago on the Amy, I got like 2 or 3 problems just by using this strategy and figuring out the pattern. So then I can prove the pattern exists and that it works. And same thing for HMMT combinatorics. The year I won that contest, like many of the problems, I figured out the pattern by testing out small cases. And then I showed the pattern was true, and then I solved the problem. Finding patterns is honestly really important. And many times you don't even have to prove they exist, because I don't recommend it, but if you can't prove them, then just assume it's true, because it's better than nothing. And more often than not, these patterns that you find for the initial few values will continue.
All right. I think that's all the content we have for today, right?
There's a little bit more about combinatorics that I'd like to bring up. If none of the strategies you think works, 2 other things you could do. So first of all, determining small cases. Observe your process, like how you find these small cases. And then maybe that can lead to a strategy algorithm that solves the problem. Another strategy is, if nothing else works, but you still have spare time, it might just be casework. You might just have to check every single case. I think that's a very important strategy, to check every single case. And this strategy is only applicable if the number of cases is not too large. If you think about it, the test writers aren't going to make you check over 500 cases. There's going to be a better way. But they might make you check over 5 or 10 cases, because if you have 5 or 10 cases, it's very doable for competitors to check over it. Again, the problem writers are monsters. They want kids to enjoy the competition and to have doable problems. So if a solution seems too hard, too bashy, too not doable, then there's likely a better solution out there that is more doable. And I recommend not just to get the question, but I recommend for also speed and accuracy purposes that you try to do the best solution. Because if you do a worse, bashier, and more time-consuming solution, that first of all makes it much more likely to silly, because you do a lot more computation. Second of all, it makes you a lot slower, because for example, if you do 20 problems on the AMC, except each solution you spend you find is 1 minute, takes 1 minute longer to find than the best solution, then you could lose 20 total minutes, 20 valuable minutes off of the test. And that's quite a lot. I recommend that you do your best to try finding the best solution. Another note on that is about practicing. So let's say you take a practice AMC and you get this problem right by bashing, doing some really long, convoluted bash. I recommend you treat that problem as if you missed it, that you review over the solution if there's a better solution, and you try incorporating that into your techniques next time. Because again, having a really long and bashy solution that takes up a ton of your time and is really likely to silly is barely better than having no solution at all. I recommend for y'all to just try finding the best solution and focus upon that aspect of finding the cleanest solution. Naveen, do you have any thoughts on this?
Just a small thing. I think people in the thread are saying that protractors and graph paper apparently are banned now.
According to the AMC rules, the AMC website, which I pulled up, graph paper is allowed for the AMC 10, 12, and AME, not for USAMO/USAJMO, and protractors are not allowed.
Okay, thank you for that. I think we're done here, right? I guess if you want to do a Q&A, maybe.
Yeah, I'll share a little bit about my own experiences with strategies and whatnot. I guess you can leave now, but I will be covering my own experiences, and I think this next part will still be pretty helpful nonetheless. Things that I've done for tests. First of all, for the AMC, one strategy I've used for the past few years is to work, is just to start from the front, right? Don't skip. If you're at the level which you think you can confidently make Amy, then don't skip any questions. Just keep going until, if you can't solve a question for 3 to 5 minutes, you still have no idea how to find a good solution, then skip it. That's something I've done, and I think it's worked. And in addition, for AMCs, I've always blocked off 15, 20 minutes at the very end to check my work. Because personally, I am not a guy that doesn't make silly mistakes. I wish I was accurate, but I make a ton of sillies. And you might be surprised at that because how does he do so well? Well, the trick is to check your work again. Because I make so many sillies, I just check over my work. I spend 15, 20 minutes, and suddenly most of the sillies vanish. The same thing for the Amy. On the Amy, it's a 3-hour-long test. My main strategy is to spend 2 hours on the Amy, solving the problems. And usually I get enough problems to confidently make the next level. And if I don't, then maybe I'll spend 20, 30 more minutes on the problems. But after that, I always reserve 30 minutes to 1 hour on the Amy to check over my work. I just look over every single step I'm doing, try finding more solutions, all of that. And it'll be shorter because, of course, you're already familiar with the problems and how to approach them. I believe that blocking off time to check your work is a crucial aspect of tests because accuracy, I think, is the most important. If you think about it like this, for example, you spend 5 minutes on a problem, right, to find a solution. And if it's wrong, you waste 5 minutes. But if you could spend maybe 30 seconds to 1 minute on the problem, check your work, and then fix the sillies, it's worth it. It's only 1 extra minute per problem. And then now it goes from 5 minutes wasted to 6 minutes getting a correct answer. So there's no time wasted. So I recommend you think about it like that, like the amount of time wasted, so that you stay accurate and you can get more questions right. Because in the end, accuracy is what's most important. Of course, if you have issues with your speed, you can't afford 15, 20 minutes or else you're not going to reach Amy or something. I recommend you follow our speed tips, which Naveen has covered. And we'll be having that on our handout, which we will post on the website. So you can read over that. Now, since we have around 5 more minutes, I will talk about my personal experiences. So I started math the first year I took the AMC 10 was in my 4th grade. So I was pretty young back then, as you can tell. But I practiced a lot, and I think good practice is the most important part. I remember before my first AMC 10, I did every single AMC 10 as practice, and I did quite a few AMC 12s as well. And doing that's crucial to gauge your ability, gauge your skills, and to see where you should aim for. For example, if you're making Amy on all your practice tests, of course you should aim for Amy and maybe even higher. Also, is to not overload your day with practice. Practice isn't about quantity, but rather quality. It's better to practice well than to just practice a lot, because practicing a lot may mean that you don't retain anything. Information goes in your brain and then suddenly it flows back out because you practice so much that your brain just pushes the previous stuff out. But if you practice well, information goes into your brain and it stays there. And then the questions you miss, questions you don't have the best solution to, you should mark them down, write them in a notebook, something like that. And then review over the problems a few days later. Try seeing if you can solve them after reading the solution and then waiting a few days. If you can't, repeat that process. And then from there, you can learn these techniques that you previously didn't know. Solve these problems that you previously didn't know how to. And that's how you improve, to get the questions you didn't know how to do previously. That is also a strategy I did a lot. That I took every single problem I missed and then I redid them. So then suddenly I knew how to do them. And because competition math is more like a toolkit, there's only a certain amount of tools that you need to use. If you can learn all these tools based on previous problems, then you're going to be really successful because you know all the tools, you know all the previous problems, and most likely that'll apply to the real AMC as well. Someone was wondering if it's allowed to do both 10A and the 12A. That is not allowed. You see, AMCs are hosted in A and B. So the A is on one day, the B is on another day. And for the A slot, you can only take 10 or 12. So either 10A or 12A, because those happen at the exact same time. But then the B is later. So then you can choose either 10B or 12B, one of them two. But you can't choose both because they happen at the exact same time. Now, someone else also asked, were you in math counts? Yes, I was in math counts. I participated back in 2016, 2017, and 2018. In 2016, I got 8th place in nationals. And then 2017, 2018, I was a national runner-up. Someone also asked, what age did you start math contests? I started in 3rd or 4th grade. My first AMC 10 was in 4th grade, as I said. And I made AMY in 4th grade, and eventually I made JMO in 5th grade. Now, another person asks, can't you bash every single problem in AMY? Because there are only 15 problems and 3 hours, and the first 5 problems are easy. But the thing is, that's really, really deceptive. You might think, wow, 3 hours is so long, but in all actuality, it's a lot shorter than you think because these problems are difficult. And like most of the time, my problem with AMY is not that I can't solve all the problems. It's that I don't have time. Same thing for Olympiads, like USAMO. You have 9 hours for 6 problems, but that's still not enough time. Like you realize as you get to a high enough level that bashing will take longer and longer. And it's still better to find the best solution because you just have more time for the more difficult questions or the other questions that you may not know how to solve. So again, don't feel like you have infinite time on the AMY because 3 hours is deceptively short. And before you know it, they'll be gone. Think about it. Like it's 12 minutes. If you spend 2 hours working on problems and then 1 hour checking like I do, that's 8 minutes per problem. And 8 minutes can go pretty quickly, especially for like questions like number 15. You'll probably need 20, 30 minutes to solve those if you ever get to that level, which means that it's actually less than 8 minutes per problem. Now, someone asked me, how much have you practiced on average daily? Back when I was preparing for I don't have an exact time. I don't remember, but maybe like there's no exact time for you to practice. Practice however much you see fit. But again, quality over quantity. Don't just say, wow, I did 20 practice tests today. I'm so good. Instead, you should do like, oh, I did 2 practice tests today, but I went over every single question I missed. I made sure to practice my strategies and I understand what I'm doing wrong. That is a lot better than doing 20 practice tests and not understanding or learning anything. Someone else asked me, what was your score in 4th grade? That was a 135. And can we go now? Sure, I guess. Now, someone also says, what are some high school contests you have done in Houston? So let me cover a few additional contests. We're over time, so by the way, anyone can leave, but I'll just keep talking for like another few minutes. Some high school contests. If you're in Texas, specifically the Houston area, like me and Naveen, there are a few good contests to attend. First of all, the UH mathematics competition. It's mostly covering school math type topics, but it's a fun introduction and you get to meet a lot of new people. Second of all, the A&M math contest. That's a bit more difficult, but it's also pretty fun. There's like something called a buzz round, which is, I think, really, really exhilarating. There's also, of course, math counts, and there's some mock math counts contest around. And then if you're at a high enough level, you can try going to PUMAC or HMMT. PUMAC is held in Princeton every November. HMMT is held at MIT every November and February. If you're at the high enough level, which like you do well on AMY, or you have a chance at like doing like making JMO or doing well in USMO, then I recommend you check those competitions out and maybe try finding a team. Of course, since they're like in the East Coast, it may be expensive to travel. Someone else also asks, because the 12 is so much harder, does it lower the JMO indices of people participating on average? I don't think it does because like the 12 only leads to the USMO. The 10 only leads to the JMO. These indices are completely separate. Now, someone also asks me, can you advise some strategies for JMO? Well, this like series isn't really targeted toward JMO, but I'll give like 5 minutes of advice. First of all, read over every single question on there. You might think like number 3 is too hard, but I think you should read over it anyways because sometimes difficulties can be deceptive. Second of all, you should spend as much time as possible. You should write your proofs neatly and in a well-organized manner. We're having our session on writing proofs and papers on Friday. If you're interested in like getting better at that or preparing for the JMO, I recommend you attend because we'll be taught by Eric Gann, who's made MOP many, many times. So he's really, really good at math, a lot better than me. Now, is there such a thing as starting competition math too late? Now, that's a great question. I say that our classes are tailored toward people of any ages because there's no such thing as starting competition math too late. While I do admit that people who start earlier have a bit of an advantage because obviously they have more time, I think people who start later still have a more mature mind, so they can think through things maybe more quickly and pick up things more quickly. So don't give up. I know a lot of people who started in 9th or 10th grade that eventually made MOP and even IMO. So there's no such thing as starting too late. And even then,
Andrew.
Yeah.
Well, when did Evan Chen start doing competitive math? He started pretty late, right?
Yeah, he started pretty late, and then he eventually got a gold medal.
Pretty sure he got like an 80 on AMC 10 in high school. So it's not too late to join competitive math at all.
Right, and also another thing is starting. If you think competition math is fun, honestly, I recommend you do it. It's a great skill to have, like to get good at math, because getting good at math, especially competition math, helps boost your logical thinking. And then being good at this logical thinking aspects subsequently makes you really good at all other aspects of STEM. And then math, like even through like high school and college, it's a lot easier for people who are like quite experienced in competition math to take college math classes and higher level math classes. So I think that so competition math is really nice, as in it helps set you up for the future as well. Have you done a math league? Mathleague.org, I've done it before. It's similar to Math Counts. I think in general, I covered all the material and all the things I've wanted to cover. A few people are asking about a few resources, so let me give some. We'll be having a lot of resources from our class coming up, as we'll be teaching our classes for the next 17 weeks about a bunch of different topics, AMC and AME level, and plus the fundamental series, and then the special seminars, which are really, really cool, and I recommend you just take a look at them because they help introduce some non-competition math things for you to maybe look at in the future, or even right now you're interested. Some other resources other than what we provide are, first of all, AOPS, of course. AOPS is really helpful, AOPS.com. It has a ton of mock competitions on there, like all the past AMCs, AMEs, USIMOs are on AOPS. They also have really nice forums to interact with other math kids, although I recommend that you don't spend too much time on those. There's also games such as FTW to improve your speed, and then Alchemist as well. And I think both of them are pretty fun. Now, someone asked, are you comfortable revealing your AOPS? Sure, my AOPS is AC_math, although I don't use AOPS too much nowadays.
If you want mine would be ANC. If you look at the Math Divulge thread on AOPS, I'm all over that thread. So yeah.
Yeah. And finally, let's see, someone says, okay, so again, other resources. Honestly, I think AOPS is a good enough resource for like all introductory level things. And I think we are also a very good resource in that sense, because like we're offering free classes for all like introductory level up to AME things. If you want to go higher, like Olympiad things, I recommend you to check out some of Evan Chen's doings. He has a lot of materials and resources he's written. And in general, and maybe take Woot, although Woot is focused toward like upper end AME and Olympiads, although it's quite expensive. Someone asked me, what was your timeline? So my timeline, first of all, in third grade, I took the AMC 8 for the first time. In fourth grade, I took the AMC 10 for the first time and made AME. In fifth grade, I took the AME for the second time and made JMO. And also, don't be discouraged if you do badly on a contest for the first time. In fifth grade, I took the JMO. And you know what I got? Out of 42, I got a 0. And then in sixth grade, I took it again. And out of 42, I got a 6. And then in seventh grade, I took it. I got a 29. And don't get discouraged. You can always improve. And then in eighth grade, I became a JMO winner, like the second highest JMO score, and I made MOP. And then now I'm in high school. I'm doing more research type opportunities, which I think is really good transition to as you get older. How do you maintain motivation when studying? That's a good question. Motivation has been something I've struggled to deal with a lot. But I think you should not think I have to study, I have to practice, and so on and so forth. If you don't enjoy it for a while, I think it's best for you to maybe take a few days break and make sure you don't burn out. It's very important for you to make sure you enjoy doing this, because that propels your motivation, and that helps make you a lot more skilled and a lot more interested in learning mathematics and getting good at it. How do you get rid of your stress during the test? I think right now I'm so experienced at so experienced that I'm not really nervous. But before, when I was like first starting math competitions, what I try to do is just like get so in the groove of doing problems, like get entrenched in them. So then suddenly I wasn't really thinking about the competition anymore. I was just thinking about the problems. And that's my advice. So try just blocking out the competition. Just think about the problems. Now, someone also asked, like, how much do you suggest to practice every day? Practicing every day, I think I've answered this question before, but it's honestly up to you. Practice enough so that you keep learning and your brain stays refreshed, but don't practice too much so that you burn out or you lose interest. But again, quality of practice is better than quantity of practice. Now, I think...
Yeah, I just want to say something. Don't be like, even though quality is greater than quantity, don't be so obsessed with quality that you forget to actually practice. Because one of the major things, Evan Chen actually posted something. Stop looking for the right training. If you go to the contests and programs forum on AOPS, it should be one of the sticky threads there. But just don't look for quality and just obsess over that.
Yeah. Like what I mean by quality is that you just have to make sure you retain the information, but don't go looking for like the best possible problems. Just do contests, do problems, but make sure when you do them that you retain the information and that you learn from them. And that's my recommendation. Yeah, this has been a pretty good meeting, and I guess see ya everyone, and please come to our next meeting, which is about writing proofs and papers taught by Eric Gan at 3 p.m. CST this Friday. So see y'all.